Hey everybody, Mr. Kaczynski here, working on the last skill in section double B of IXL's Algebra 1 skills. So here we go, systems of linear and quadratic equations. We got a system of equations. One of them is quadratic, the top one, and one of them is linear, the bottom one. And we need to find the point or points where this parabola crosses this line. That's the solution to the system. We can use substitution method though, because they're both set equal to y, and y will always equal y. So I'm just going to say that 2x squared plus 48x plus 24 is equal to 40x plus 16. And we're going to be able to do this on pretty much every problem in this skill of IXL. All right, and then I'm going to get it into general form where all the terms are on the left. So to do that, I'm going to subtract 40x from both sides. That would leave me with an 8x. And I'm also going to subtract 16 from both sides, which would leave me 8. All right, now we've got options. We can use the quadratic formula, we can try and factor, we can complete the square, whatever method you have for solving a quadratic equation. I see that all these terms are divisible by 2, so that's the first thing I'm going to do, is divide them all by 2. And then I see that this is a perfect square trinomial that can be factored. So I'm going to solve this by factoring. So x plus 2 times x plus 2 is x plus 4, x squared plus 4x plus 4. The square root of x squared is x, the square root of 4 is 2. When you multiply x times 2, you get 2x doubled is 4x. So it's a perfect square trinomial. Then we'll take the square root of both sides, and that's pretty easy because the square root of 0 is just 0. And then we'll subtract 2 from both sides, and we get that x is negative 2. But we're not done yet because we need to figure out what y is. You can plug that x value into either equation, but it's usually easier to plug it into the linear one. So 40 times negative 2 plus 16. Y is negative 80 plus 16, and negative 80 plus 16 is negative 64. So that's our solution here. It's negative 2, negative 64. That is the only place where that parabola crosses the line on the coordinate plane. Let's do another. Same idea. We have a linear equation and we have a quadratic equation. We want to find out where they cross each other. Okay. So I'm going to set them equal to each other. Since they both equal y, they must equal each other. So I'm going to put my quadratic one on the left and my linear relationship on the right. Now I'm going to get it into general form. So I'm going to, I'm going to subtract 9x from both sides. So that would be x squared. And then I'm going to add 24 to both sides. And negative 33 plus 24 is negative 9. So I'm going to use square roots to solve this one. I'm going to add 9 to both sides and then take the square root of both sides. And remember, every positive number has 2 square roots. So x equals positive or negative 3. Now I'm going to take this linear equation. I'm going to figure out what y is. Y is 9 times 3 minus 24. Which is 27 minus 24, which is 3. So one point where these cross each other is at 3, 3. When I put 3 into this, I get 3 out. But there is another value of x. So let's do this again with that second value of x. 9 times negative 3, because x could be positive or negative 3, which is negative 27 minus 24, which is negative 51. So the point negative 3, negative 51 is also a solution to this system of equations. So this one's got 2 solutions. They're both points. All right, another one. I want to show you some different things that go on here. Again, they're both equal to y, so we can set these two expressions equal to each other. All right, so I'm going to again put them into general form. So I'm going to subtract 41x from both sides. And that's going to give me negative 9. 32 minus 41. Yep, it's negative 9. So negative 9x. And then I'm also going to add 36 to both sides. So that's positive 14. Since the lead coefficient is 1, I can look for factors of 14 that add up to 9, and this is factorable. In fact, when I did this entire skill all the way up to a SMART score of 100, I never came across one that wasn't factorable. So negative 7 and negative 2. Negative 7 times negative 2 is 14. Negative 7 plus negative 2 is negative 9. So we can use the zero product property to say that the solutions to this equation are 7 and 2. But remember, we're not done yet. We need to figure out what y is. Y is 41 times our x value minus 36. So 41 times 7 minus 36 is 251. So one point that works is 7 to 51. That's one of our solutions. And our other solution is going to be 41 times 2 minus 36. 41 times 2 minus 36 is 46. So our other solution is 246. Two solutions. I'm going to do one more and just remind you that you can always use completing the square too. So I'm going to solve this one with completing the square, even though it can be done with factoring. We just take these two expressions and set them equal to each other. We're going to do that every single time here because they've always got y isolated in both equations, so that makes it easy for us. All right, this one I'm going to add 29x to both sides, which is going to give me 18x, but I'm also going to subtract 11 from both sides. So that gives me negative 32. And then I'll complete the square to do this one, just for fun, why not? So I'm going to take half of 18, which is 9, and square that, which is 81. So I'll add 81 to both sides. And then I'll factor this perfect square trinomial that I just created, x plus 9 squared. Negative 32 plus 81 is 49, perfect square, meaning, yes, it was factorable. We'll take the square root of both sides, plus or minus 7. So x is either negative 9, it's negative 9 plus or minus 7. So negative 9 minus 7 is negative 16. Negative 9 plus 7 is negative 2. Those are the solutions. And then we can go ahead and figure out what y is. So y, actually, check that. I'm going to use the linear one. So we'll do negative 29 times negative 16 minus 21. I'll just punch that into my calculator. Negative 29 times negative 16 minus 21 is 443. So one of our solutions is negative 16, 443. And we've got a second solution here, which is going to be found by doing negative 29 times our other x value that we got, negative 2, minus 21. So negative 29 times negative 2 minus 21 is 37. So our other solution is negative 2, 37. All right, so systems of linear and quadratic equations, basically solving quadratic equations and then using the solution to find y values. Good luck. Let me know how it goes in the comments.